recording is in progress. Thank you very much. Okay, so as we all know, we are looking at the exploratory data analysis for early to mid career researchers. So we are going to go into some of the things that you need to be able to have a very successful career as a researcher, as a data analyst, or as a professional marketer, professional educationalist, a professional policy person. And basically, there are some basic things that you need to know so that at least you can have that successful journey. Statistics is very broad, or data analysis is very broad, which we cannot just even use 4 years or even 5 years to even finish, or even 8 years. Even at your PhD level, you can't even finish everything. But you need to be able to do consistent practice to be able to get there. Yes. So as you are able to get basic understanding to issues, you'll be challenged with more difficult tasks. And then through that, you're also able to learn. But if you don't get a foundation right, it makes it difficult for you to get to the higher level. So I'll urge each and everyone to be very, very active when it comes to research and data analysis. And I believe strongly that it will put you somewhere some years to come. So the class is more practical based, going to be more practical. But before we start with the application, we'll just need to go through the slides for today, just about 10 minutes or 15 minutes rush. And then we will take the data, then we begin to work on. If you have question, please just raise your hand and then ask your question. If you want to wait till the class I finish with the presentation to is also there. But I believe strongly that for you not to forget it, to be appropriate, you ask the question as we move on. Thank you very much. Okay, so you already, my name is Isaac Oforia Sari. I'm currently in the US for a terminal degree, and I also serve as a lecturer at Accra Technical University. And these are my research interests, as you can see on the screen. Machine learning in biostats, obesity and lifestyle-related research, causal inferences, and so on, plus other things that I am doing more research using statistics and data to make decision on. Okay, so outline for today's presentation. We will be looking at what exploratory data is all about. We go through the difference between the exploratory data and then the confirmatory data a bit. Then we look at the overview. We look at descriptive statistics and data visualization. And then we explore into the relationship and then that of what other variable, relationship between variables. This is where most of the statistical techniques will be used. Yeah, so here you can just see it exploratory relationship, but there are so many things that we are going to learn at the end of, let's say, the class or the meeting today. Okay, so let's begin. When we talk about exploratory data analysis, or what is all about this exploratory data analysis. So we are saying that exploratory data analysis is all about one, as a researcher or as someone who wants to go into data. The first thing that you need to do is to be able to have time to examine the data that you have. How do you examine the data? You need to examine the data by looking for certain things within the data, such as, let's say, patterns, trends, or some noises within the data set. That is the the abnormalities within the data set. And then certain distributions, you check the distributions of the data. How do you do that? You can just look for whether the data is skewed or it is not skewed. These are some basic things that you need to know. And then you must also look for what is called missing observations. Okay, so missing observation and certain huge or strange values within the data set, which we call outliers, right? So these are some of the things that you need to know. And then based on that, you can make your informed decision as you progress in your analysis. So please, these three things that you can see over here, you need to deal with them first before you even move on to the higher analysis, or before you start with your data analysis proper. So irrespective of where you find yourself, irrespective of the kind of task that you are performing, don't be in a hurry to apply further statistical techniques on your data if you have not taken time to go through this kind of principles, observing patterns, trends, or let's say some behavior about the data. Because if the data is not well structured, if the data is not well organized, and you apply these further statistical techniques on just to make decisions, at the end of the day, you might get it wrong. That is why it is good. You should spend almost close to about 40% to 60% of your time just exploring your data, or just doing data cleaning and some manipulation. Once you are able to get a very clean data set, apply your techniques, or you knowing the kind of techniques to apply on your data should not be an issue at all, right? It should not be an issue at all. So I'll urge each and everyone to have time. So if you are gathering data, maybe you've started with your research work, or you are working for an organization, they've asked you to go out there to collect data, or maybe your student project work or thesis. Please, once the data is in, remember, some people will not respond to some of the questions. Remember, some would, instead of them entering one, they will enter 10 and so on. You need to have time to go through all this step by step, right? Before you start to apply, oh, let me use regression on the data set. Let me use time series on the data set. Let me use this. That is the further statistical analysis that we are talking about. So please have time to check all this before you start with the analysis. Okay, so now what is the difference between the exploratory data analysis and what is called confirmatory data analysis? These are two technical things that you need to know, right? And our next session would be more of the higher dimensions. That is, those who are doing, let's say, MPhil, masters, MPhil, and PhD. We will be targeting them for this kind of analysis. That is what's the name? The exploratory. We have what is called the exploratory factor analysis. Now we have what we are doing now is exploratory data analysis. We have exploratory factor analysis and then confirmatory factor or confirmatory data analysis. These are technical areas that goes into that higher dimension degrees, master's degree in humanities, marketing, whatever, HR and so on. They use it a lot. That is the humanity side, right? So we'll be targeting those people. That is in our next session, exploratory factor analysis, and then that of what confirmatory factor analysis or data analysis. Now, the EDA is just focusing on discovering insights. You just want to explore the data to just know what is happening, as I said, by checking all these kind of basic things that we are talking about. I'm just saying basic, but it is not just basic as it is, because if you get it wrong, it's going to affect the entire work that you are going to do. And then if you look at the confirmatory side, This is where you formulate a high dimension hypothesis. So you can make a hypothetical statement that organizational training has impact on, let's say, performance or employees with performance, right? And then you go out there and collect data. Now, maybe you are collecting data on performance using about 6-point scale, asking 6 questions to measure performance, asking 6 questions to measure, let's say, training. How do you analyze this kind of data? Here, you cannot just analyze it anyhow, the way we do the normal analysis, like using regression. You cannot do that. Regression cannot help you in this regard. But there is a higher dimension too that goes beyond regression. That is what you'll be looking at. That is the confirmatory aspect of it, right? So the confirmatory is more on that's high dimension hypothetical formulation that can help you to get insight into your data set, right? So that is the difference between the exploratory data analysis and then that of the analysis for people in that caliber, master's, MPhil or PhD level, or anyone who is interested in learning advanced analytical or data analysis to help make informed decision. Okay, now these are some of the basic assumptions or hypotheses that you can formulate. Let's say you want to just say that you are examining the impact of what diet on what blood sugar level. This is a simple hypothesis that you can formulate, right? And then we are saying that the EDA helps visualize sugar level distribution. So in this case, you are only using the exploratory data analysis to see the picture or the beauty of the dimensions, or let's say the distribution of the sugar level. Depending on how you are going to measure that kind of variable, how are you going to measure diet, right? Are you going to use questionnaire? If you are going to use questionnaire, will you be drawing some graphs? Will you be using some tables, some basic things? Those are the things that we are talking about, that the EDA can help you to be able to do that, right? To be able to answer that. And then to examine the relationship that exists between the two variables, this is where the hypothesis what comes in, right? So assessing the relationship between diets and blood sugar before what formal hypothesis formulation is what is done. So let's get the understanding of some of these basic things before we just rush into the higher analysis, or before we rush performing the statistical analysis. So that is the key difference between the two. All right. Please, any question? Do we have question before I proceed? Okay. All right. So if there is no question, once, as I said, if you have question, just raise your hand. We will just attend to you. Good. The next thing is overview of what SPSS. Now, SPSS is one of the commonly used statistical software that is used to analyze simple, moderate to complex data, right? It's not appropriate for qualitative data unless you code into a numerical form to be able to use it. But it is a very complex statistical software that enables us to do a lot of analysis. Now, if you say you know how to use SPSS, that is fine. But the question is, do you really understand those techniques that are in it? So the statistical software SPSS is like a textbook that has pages inside. It has pages inside. So you take a particular textbook that has page 1, page 2, page 3. Now in the software, you open it and you see a text over there. So those are the tests that at the end of the day you'll be using, or those procedures that you can see them in it. That is what you'll be using to do your analysis. So if you say you know SPSS, sometimes you ask some people, how do you know this software? Oh, I use it to do this. Oh, I am able to use it to do this. But do you really understand some of the things that you see inside and you can use them effectively, or you've just heard of the name? So we will go through the overview of the software, and then from there, we can use our data sets for the work itself. So we will look at the data view and then that of the variable view, how you can also get data into the software, and how you can also set up the labels and so on. Okay, now let's look at descriptive statistics and data visualization, right? Now, when it comes to descriptive statistics, they enable us to have an overview of what the data set or the variables that we have. So mostly we can use like the mean, median, mode, standard deviation, and so on. And then the measures of dispersion, that is the variance, and so on. Then to check the distribution of the data, we use what is called the skewness and kurtosis, or we can further perform tests like Kolmogorov test and Shapiro test just to get the distribution of the data. Remember, getting the distribution of your data helps you to perform certain tests, because at a certain point in maybe in your career, you will be writing articles for publication. You'll be writing articles and then you will be sending it to journals or maybe media, certain publication houses for them to one review. And some of this is when you don't perform them, they will reject your paper. So many papers have been rejected because some of these, let's say, researchers could not go through basic things like checking the normality, checking the skewness, and so on of the data set. So they are very, very basic, but they are very powerful. That can either make you or unmake you. So let's take note of that. Now, the visualization, you can use basic graphs, pie charts, bar graph, histogram to tell a story that maybe you have, right? We should also not think that graphs are not what powerful. In fact, graphs are very, very powerful, right? If you're able to use an appropriate graph to tell a story, it is more even powerful than you using any big statistical techniques, right? Where people don't even understand the kind of story that you are saying. So it is all the time appropriate to use some of these things, depending on the kind of presentation that you are going to make at your workplace, right? All the time, I've been saying that just check statistical service, Ghana Statistical Service, their reports. Most of them are just basic statistical procedures like tables, simple percentages, and charts. But at the end of the day, it tells a lot of our story that anyone who takes or maybe take your report really understands. You don't need to have a technical background for you to know the tallest or the shortest or the average. You will just see, right? So statistical service, for example, they give you the basic information that you need. So if you're a researcher and you want to get more insight as to what they have done, then you go for their data, then you begin to apply all this, your statistical know-how on it to tell what a story. I have used their data for publication. I have used their data for research. And what happened? They presented basic stuff, but I took their data set and then went into what? Make informed decision, right? So these are some of the things. You can just use basic stuff like pie charts, histogram to just give that kind of a story that maybe you want to give to, depending on the caliber of people or persons that you are presenting to, right? Once you use those higher things or higher statistical tools for your higher dimension kind of what research. Okay, now we are looking at relationship between what variables, right? Now, there are so many relationship tools that are available that even time cannot even permit us to go through all of them, right? Now, but one of the basic tools that we use is what is called, okay, Sally, place your hand is up. You can unmute and then ask your question. Thank you. Before I move on. Madam Sally, your hand is up. You can unmute. Hello.
Yeah, please, can you hear me?
Yes, please.
Yes, I just want to plead that if you can slow down a bit so that we can follow. If you can just walk.
Okay.
Thank you.
All right. Okay. Okay. All right. Thank you. Okay. Good. Good. So, establishing relationship between another hand is up, or is it an old hand? Okay. All right. So, establishing relationship between variables, right? There are so many techniques that are available that we can use to, do that. But one of the commonly used technique is what is called what? Correlation, right? So correlation is all about establishing relationship or strength of relationship between linear variables or two linear variables. Here I am choosing my words carefully, right? Correlation is for linear relationship between variables. So if the relationship between the variables is or are not what? Linear. Please do not use correlation, right? There are several relational techniques, right? Some of them are nonlinear, some of them are polynomial, some of them are quadratic in nature, right? So if you check the relationship between the variables and it doesn't look linear, right? Please don't use correlation to do the reporting. There are so many techniques that are available. As I said, we have the cubic correlation, we have the exponential, we have the quadratic, and so on. They are all there. Maybe your data follows what? Quadratic, or your data follows what? Polynomial, right? Please, it is better you use such tools to what? Report, rather than to use what? Correlation. Correlation is for linear relationship, right? That is, you are looking at the impact of, let's say, your income and then price. You can see there is some kind of what linearity between the two, right? Because if price goes up, it also affects what? Your income, right? And vice versa. So what you need to do is first, you can plot the relationship between the two variables and see if they are having that linearity, then you can what? Assume it. Else you need to look for another technique for such. Okay. And correlation takes values between 1 and then let's say plus or minus what? 1, right? So correlation can be 1, that is positive 1. It can be negative 1. Correlation can also be what? 0, right? But mostly you cannot get just 0. You cannot get 0. It is not normal for you to get 0. At least you are going to get some kind of relation, right? But that relation might not be significant. Okay, it might not be significant, but for it to be 0, well, if it is 0, then it means that there is no correlation at all. As I'm saying, that would be weird, but if it happens, that is fine. So let's have it in mind that you can have positive correlation, you can have negative correlation, right? Positive simply means that the two variables moves what? Together, right? So all other things being equal, like if your income increases, or let's say if your educational level increases, right? From, let's say, from your first degree to your master's degree, your salary must also correspond. Or if you have served, or if you are in the industry for some number of years, it must also correspond with that of what your income. All other things being equal, right? That is the positive correlation that we are talking about. And then when we talk about the negative correlation, that is the opposite. So it's like as one of the variable increases, right, the other one what decreases and vice versa, right? So as one increases, the other one decreases. So maybe you have let me just so use the income and then education, right? Elsewhere, as your income, as your educational level increases, your income also increases. Elsewhere, even if you bring PhD, your income is still at that same level. If you bring your master's degree, your income will still be at that level. If you have your what's the name, your first degree, still your income is this. If it is like that, then there is what a negative kind of what relationship, because as you are even progressing, you are progressing to the highest level, your income is still at the bottom. That is what we are talking about, right? It is very, very important to know this kind of what correlation. You can have significant correlation that is negative, and you can also have significant positive what correlation. So if you are doing a test and you have negative correlation, don't say that, hey, I have negative correlation, so it doesn't make sense. It makes sense, but it's just that the relationship that exists between your variables, right, they are what inversely what related. Let's take note of that. Okay. Now, importance in data analysis, that is, why is it so important? Why is it so important to check for correlation in your data set or within the kind of research that you are conducting? So we are saying that it helps you to be able to what? Establish the relationship. There is something we called collinearity, right? As we move on, it will come there, collinearity. How do you do that? You can perform collinearity with just a simple correlation. We don't want variables to correlate too highly, okay? We don't want the situation whereby variables correlate too highly, right? And we don't also want a situation whereby they correlate too simple or too low. But there should be correlation at least from 0.3 to points around 8. So correlation can help you to be able to know that, oh, two variables are doing the same job in the model, so I have to drop one. These are some of the importance of you understanding correlation and what it can also do for you, right? Then helps in predictive what modeling, right? So using one variable to predict the other, it can help you and also guide you for further analysis and that of what decision what making, right? So these are some of the reasons why it is important to have a better understanding when it comes to correlation. Okay, now there are several types of the correlation, right? Some of them are known as what? Parametric what? Technique. Now, the parametric techniques assume what is called normality. It is not all the time that you need to perform correlation on your data. You need to check the nature of your data. Ask yourself, is your data normal? If your data is not normal, there are certain correlation that you should not perform and others that you need to perform. Let's take note of that. Now, the first correlation is called Pearson. The Pearson correlation is used or should be used only when your data is normal and you don't have strong or enough outliers within the data set. Let's take note of that. We should not be in a hurry to go and perform correlation. Check whether your data is normal before you perform what is called Pearson correlation. Pearson correlation should be used when your data looks what? Normal. We have what is called the Spearman and then Pender what? Correlations. These are the type of correlation that do not assume what? Normality, and they are they are what is called what? Non-parametric what? Techniques. So if your data is not normal, right, you can go ahead and perform correlation, but here use Spearman or what Kendall what correlation for such kind of what analysis. It is very, very important to take note of that, right? Good. So let's take note of this type of what correlation. We also have what is called the biserial correlation, which is also a type of technique that is used to measure the strength and direction of relationship between one continuous variable and then a situation whereby you have what is called what a categorical variable or what is called a binary variable. So you want to perform correlation between a variable like, let's say, income, which is a continuous variable, as against gender, which has what? Male and female, right? Good. So gender here is what? A categorical variable, right? Or a binary variable. And you want to what? Find a correlation between the gender as against an income. That is a continuous variable. The kind of test or what that kind of analysis is what is known as what? Biserial what? Correlation. Let's take note of some of this so that when we are reporting some of these things in our papers or in our research works, we will not do the other way around, right? So that we report it accurately, so that whoever takes our report will really understand or know that we really understand what we are doing. Okay, so let's take note of some of this basic correlation types that we have. Good. Now, please, any question? Do you have question on where we've gotten to so far? From the beginning to where we have the difference between Pearson correlation and then Spearman, Kendall, and so on. Any question? Then we move on. Any question? Please, do you have question? Okay. Then, if there is no question, okay, please go ahead, sir.
Please kindly go through the table again, with all due respect.
Okay.
Yes.
All right. Okay. Good. So here we have the Pearson. So the Pearson, the data type that it takes is what? Continuous. Continuous is just like a numerical variable. So for example, our income. So my income, your age, your height, your weight, and so they are all continuous what variable. And then it measures what linear relationships. And we are saying that before you are able to use this kind of correlation, right? Your data must be normal. There should be normality, right? There should be this kind of what linearity. And then you should not have what outliers within the data set. In other words, let me not even use no major, because sometimes you might not, just one outlier can even influence the entire result. Okay, just one value can affect the entire data set. So let's say that it should not have what outliers, right? It should not have what outliers, right? So that is about what the Pearson correlation. So most commonly used when assumptions are what met. So you need to go through all this kind of small tests to check. If everything is okay, then you can go ahead and perform this kind of what correlation for the Pearson. Then the Spearman. The Spearman is also used when you have what is called this ordinal data, right? Ordinal data, or when your data set is non-parametric. Remember, we have, as I said, we have what is called parametric. Parametric data assumes normality, or any form of data or any data set that assumes normality, right? It is classified under the parametric what? Data set, or let's say models, right? If the data is non-parametric, it means you gather the data anyhow, right? Or maybe you were just picking things anyhow. So for example, you are doing a study involving children and adults. For example, if the variable of interest is age, You are taking someone who is just 1 year old, picking somebody who is around 99 years old, and so on. When you do the analysis, you realize that there will be strange values within the data set, right? And at the end of the day, it will not reflect, because we have, let's say, children below 5 years, right? Their information is quite different from people who are around 20 years and above, right? So why don't you just focus on, let's say, children below 5 years, deal with them separately, whereby you are not going to have a huge value or age like, let's say, 45 within that data set. The moment you are having this kind of values within children data set below 5 years, such values will introduce what is called outliers within the data set, and it will make the data not normal. Then you move from the normality to the non-normality. That is the non-parametric approach. And with the non-parametric approach, we have its own techniques that we use, which may be, as we progress in our training sessions, we would treat only non-parametric statistical analysis and how you can use them in your research. Because it is not all the time that you can get a normal data set for your research work. For that one, let me just be sure about it. It is not all the time that you get the normal things to work with. A time will come, you just go out there, be gathering data anyhow. You should be able to get data, statistical technique to analyze that. So we are talking about the monotonic relationship, right? And then we are moving at the assumption, no normality needed. You don't need to, with this kind of, from the Spearman down to the Kendall, you don't need to have anything like normality. Just gather the data anyhow, and then just use it for your analysis, right? So that is all about the different types of what the techniques. Please, is it okay?
Yes, please, sir. I'm okay. Thank you.
All right. Okay. So
Hello,
let's.
sir.
Yes, sir.
Hello.
Hello,
Sir,
please.
so what about the discrete data?
Okay. So if you have a discrete data, discrete data, like, can you give me an example? Hello.
Hello, sir.
Yes. I can you give me an example so that our colleagues will understand an example of a discrete data?
Maybe age of 24 years.
Yes, so that is the exact ages, let's say values, right? So you need to ask yourself, what are you correlating against? So if you are correlating a discrete variable like age that has exact 25, 26, 27, 28, and so on, or whatever, right, with no decimals, and it is normal, right? You have done your examination on it and it is normal, right? You can do a correlation against other variable which is also normal, right? But you can still go ahead if it is not normal. If the age variable is not normal, then you need to move from the Pearson to a Spearman. Okay, or something like what? The Kendall. If maybe the motive of you gathering the data is to rank, let's say something like the ages of what? The participant. You can equally do that, right? So please, all the time, one, the domain knowledge is very, very important. The purpose of the study, right? What is the motive? Because one of the techniques is for ranking. Are you ranking people's age, or what are you doing, right? So once you have all this domain knowledge, it should be able to help you to choose the appropriate, plus the test that you perform on the data should help you to be able to determine the appropriate statistical technique in terms of the correlation for the study. Please, is it okay?
Yes, please. Thank you.
Okay, thank you very much. All right. Please, any other question? Okay, so let's move on. Let's take our data set and just get let's open SPSS. Let's get overview. Let's get overview of the SPSS, and then we can begin our analysis from there. So let me open or launch my SPSS. Let me launch my SPSS. So let me share my screen. Okay, so this is SPSS. As you can see on the screen, this is SPSS, and it has the procedures as follows. It has the file menu, edit, view, data, transform, analyze, graphs, utilities, extensions, window, help, and so on, right? If you click on each of the procedure, there are a lot of information that you see. If you click on the file menu, there are so many things that you'll be seeing, right? The same way, if you click on the edit, you see a lot of information. If you click on the view, you will see a lot. If you click on the transform, you will see a lot. Can you see my screen, please?
Yes, we can see your screen.
Okay, good.
Yes, I can see your screen.
Okay, thank you. Analyze, you can see a lot of techniques there or procedures there, right? And so on and so forth, right? So this is the interface. Now, the program has about 4 main views. It has about 4 main views. Now, the 2 main views are what is called the data view. The data view that is below the screen, or let's say below, just below where you have file edit. Below it, down there, you see data view, and then you see what is called what variable what view. And you can toggle between these 2 views. You can click on each of them, and then if you click on the variable view, you will see name, type, width, decimal, label, and so on. If you click on the data view, that one you will just be seeing var1, let's say var over there. That is the variable of interest, right? So that is about the 2 main views here. We have another view that is called the output view. The output view is where you get your result after you run the test. So the result should be somewhere. And you have another view which is called the script view. That is, if you want to do advanced analysis in the SPSS by incorporating Python program and R programming, right? You can use those scripts side to run it. Okay, which we are not going there at all. So it has the data view, it has the variable view, it has the output view, and also has for the scripts what view, right? So these are the 4 views that you have or we have in the application. Okay, good. Now, let's assume before we take our data set, before we get to our data set, let's just see if we can just enter some data in SPSS. That is for the first time. What we have is it has already been entered. So we don't really see the challenge involved. Let's try to just enter our own information, right? Okay. Now, let me just share a questionnaire with you. Let me just show you something. For example, if you have designed your questionnaire of a certain level or a certain caliber, and you want to, let me just share some brief information. Okay, so for example, let me share. Okay, so for example, you have this questionnaire. Let's assume you have this questionnaire. What is your gender, male and female, right? Where were you born, right? And so on. What language do you speak, and so on and so forth. So let's just assume that we just want to just use the first, let's say, 2 questions, right? Age. Now you can see age here. The person just made it what opened. Age is not closed. The person did not give the range for the age. So here you are expecting the participant to enter his or her age, maybe 35, 26, and so on. How do we do that in SPSS, right? And then another question is gender. Here, the person provided male and female. How do we code? Now, the person says that, or the researchers are saying that if you pick male, we should code you as 0. If you pick 1, we should code you as what? Let's say female. So 0 is male, and then 1 is what? Female, right? How do we do this simple thing in SPSS, right? We need to be able to do that. So let's go back. Let's go back to the SPSS. Let's go back to the SPSS and see how we'll be able to do that. Okay, so I am taking. Okay, so this is what I have. So all that I need to do is go to the variable view. Go to the variable view. That is where we design or we describe all the variables. So you go to the variable view, and the first variable is what? Age. You can just type age there. Now, what is age? Or what are you expecting the people to enter? You are expecting them to enter a number there, a numerical value. Your age 35, 36, and so on. So once you click on age, you see type, right? You see type. That is the data type. What type of data is age? Now, if you click in this button here, that's the numeric, you see the numeric, you see comma, you see dot, scientific notation, date, dollar, custom currency, and so on, right? These are data types that are available when you click on the type. Now you have the width also over there. The width is going to contain the type of response that you are going to enter there. The default is what? 8. But if you are going to enter more information that is going to occupy a lot of space, you can increase it or decrease it to suit the kind of value that you are going to enter. Then if you have decimals, for example, our income is let's say 2000.06. That is 2000 Ghana cedis, 65 pesos. So if you want to include the pesos or whatever, then you should increase the decimal to what? To let's say 2 or 1, depending on the nature of what the value, right? Then the label. So here, I'm particular about the label. The label is what is going to describe the variable name age. Okay, so the label is going to describe the variable called what? Age. You have given a variable name called age here. You need to describe it. Why is it important for you to describe your variable? So that you can, okay, Sir Anthony, your hand is up. You can.
Yes, please say. When
Yes,
I
sir.
click on the type, I didn't see numeric there.
Okay, so you click on the where there is where the type is, right? The variable
Yes.
name, there is a button. There is a button. Click on the button just after the name that you assigned, right? Can you see my screen?
Yes, please.
So you can see name here. So the next, let's say column is where you see the data type. So just click inside. Just click inside as if you want to enter something in there. Just click inside. You see the data types.
Okay, I've seen it. I've seen it. Thank you.
Okay, thank you. Good. So the label will help you to describe age, right? For example, what if I just enter, instead of age, I enter K1? How will you know that K1 is what age? So I need to come to the label and say that, oh, this is age of the participant, or let's say the field, let's say participant. So K1 simply means what? Age of what? The participant, right? So it is all the time very, very important. Remember, a time will come. You might be working in different places, right? You will be in Kumasi, somebody will be working from Tamale, somebody will be working from even outside the country, right? If you don't describe it and you are working on a project, how would the person know that K1 represents what? Age of what? The participants, or let's say age of what? The people. It is very, very important so that you can share information on a common platform, right? You can share information on what? A common what? Platform. So please, all the time, give labels to your variable name. Give labels to the variable name. And now, when you come to, so let me go back to K1 and make it, let's say, age. Good, so I have the age. Now, here, the person is going to enter, let's say, a discrete value, or let's say a continuous what? Variable, or a value, right? So here, if it is about the person providing you with the value, there is no need for you to get what? Let's say value what? Label for it. You don't need to do anything here, right? You don't need to do anything. But let's take the next what? Variable. That is what? Let's say gender, right? Gender. So we type gender. Now, remember in the questionnaire, the person has introduced what is the name? A question that is 0 for male and then 1 for what? Female. Let's take note of that. That's in the questionnaire. The person said 0 for male and then 1 for what? Female. So we need to code it. And coding it, you need to make the data type what? A number. Okay. So you come to this side, also give a label to it by saying that, oh, gender of the participant. You can write it, gender of what? The participant, right? Participants, gender of for the participant. But when you get to the value, or where it's written values, right? Click in it, you will see something like value labels, right? Now, what is the coding for male and female? The person said 0, or the researcher said 0 is what? Male. And then 1 is what? Female. So once you click in that button, right? You click in that button, you will see value. Put 0 there, and then the label, you type what? Male. Then you can add. Please, can you see my screen? Is it showing?
Yes.
Okay. And then you type add, or you click on the add. Then go back again, enter 1 for the female, and then you just click on what? Add. That is all. Okay. So then you click on OK. You are done defining the two what? Variables. So if you also have age variable that has been grouped, right? You have to do same like what we did for the gender. Please, any question, any difficulty with the definition of the variable? Okay, say Anthony.
Oh, sir, please.
Yes.
Sir, please, now, in the case of the age, whereby it was made open for them to specify,
Okay.
so which value do you give to that particular column?
So here you don't give any values for it. Just leave it because they are going to enter it. But a situation whereby you are limiting them to select, this is where you have to code those things at the value side. Please, is it okay?
Okay, sir. So in this case, whereby we made it none, would the SPSS analyze it?
If you say none for which one?
I mean, I'm talking about the age. We don't have a value there.
Yes. So if they do not provide at all, right? If they do not provide at all, right, they will not enter anything there. So here you can say that you can decide to create what is called missing section for it. But because they are going to provide, if they don't provide, the system will show at the end of the system will show that there is what missing observation in the data set, and you can treat it as that. Okay. So I don't know if I've answered you. None means
Yes,
what?
yes, I've understood you.
Okay, all right, good. So after you have defined your variables, right? Remember, you are going to have a lot of what? Variables in your study. Sometimes you can have more than 100 variables in your study. You need to take your time to define all of them, 1 up to 100. So if you check some of the studies that Statistical Service has been conducting, they have more than 200 variables in their study. They will be asking questions on housing. They will be asking questions on education. They will be asking questions on transportation, a whole lot of questions. And you need to have time to define all of them one after the other. And it makes it difficult, but it pays. Because tomorrow you are going to transfer the work to somebody to also work on it for you. If you don't do it like that, nobody will understand what you are doing. So please code where you are supposed to code. Please do code so that once you transfer your work, somebody will understand what you are asking him or her to do. Now, after you are done with the variable label, then you go to the data view. Okay. Sir Alexis, your hand is up. Please unmute and ask your question.
Yes, I still want us to go back to the age aspect.
Okay.
I think the previous participant asked whether if the age is left open, I think there is still a way that we can code that. So
okay.
I was thinking you explained one because there are instances where you leave the age question open so that they will just give their age and then you will now categorize it. Okay. And in SPSS, you now tell us how that categorization will be coded.
Okay, thank you. Yes, I understand you perfectly. Yes. Now, there is a reason why somebody will make, let me take it from this side. There's a reason why somebody will make the code open, let's say the variable open, meaning the person wants to get more information for further analysis, right? Now, after the person has been able to get the data, you can recode, which we called recode. You can either recode into different variable or recode into same variable to replace the original one, right? So if you want to use that variable for further analysis, right, you leave it opened. So once the data is now in and you are about starting your analysis, you can now categorize the variable age into, let's say, 18 to 35, one group, then 35 to 30, 36 to something, another group, and so on. So that one can be done, right? So let's try to enter some few data set, or we can use the actual data set that you'll be using because of time, right, for such tax. Okay, so Alex, are you okay with that?
I'm okay. I'm okay.
Okay. All right. Thank you.
Yeah.
Okay. Then another hand is up. Please go ahead.
Yeah, please. I just want you to highlight briefly on the rule, the last column. The rule. You see that all of them are picking input. If you can.
Yeah. Oh, okay. Okay. Here it does not. It has no impact on your work. It has nothing to do. So mostly you just ignore it. It has no rule. It has no rule. You only click and you see the inputs, the targets, both none. It has no rule on your analysis at all, right? The one that I must say it has a role to play is on the measure, okay? So depending on the type of data set that you have, right? SPSS categorize all our data set into 3, but it combines what is called the scale and then the interval as one, called what? Scale. So if you click in the measure button, you see scale, you see ordinal, and then you see what? Nominal what? Data. So if your data is scale data, it means it's a continuous variable. It's like a number, a numerical number. That is something like your income, your age, your height, and so on. So any data of that form will be under what is called scale, right? And then we have the ordinal data set. Ordinal. So something like maybe if you are ranking your data from agree to strongly disagree or disagree to agree, this kind of, you can, if that is the motive of the study, you can select what? Ordinal data. Or you have just nominal data, right? Nominal data, like a data that categorical data that has no special, let's say, impact. That is, the difference between the other is not or is not indicating any impact. So if you are a female, like gender, for example, is just let's say a nominal data. But the moment you place emphasis on a male, right, then it's moving from the nominal to what is called ordinal, because you are adding more weight to it. So if it's just about category, then you can go for the nominal data set. Okay, so Alex, your hand is up. Or is it an old hand?
It's an old hand.
Okay, thank you. All right, so let's know the type of data set that we have so that we can select the appropriate measure for it. The align left or right, it has no impact on it at all. Okay, so after you are done with the definition, then you go back to the data view. This is where you are going to enter the data set. So now you have defined your variables. Now, the next stage is what? To enter the responses from the field. How do you do that? So just click on the data view. Now, so if it's about questionnaire, right? You took questionnaire out to the participant. Now, the responses are in. You use, let's say, a paper, right? You do not use electronic form like Google form or any other technology to gather your data, but you use a paper one. Once you gather the data, what you need to do is you need to what? Number all the questionnaires. Number all of them. So question 1, question 2, question 3. If you gave the questionnaire to about 200 people, you need to what? Give codes to all the 200 what? Papers, right? So that you pick the first one, you know that, oh, this first one is for respondent number 5, respondent number 10, number 5, number 6, 7, 8, 9, 10, and so on. So the first row here, as you see, all other things being equal, is for, let's say, respondent number 1. Now, the row is what? The respondent number 1. You can see age, that is the variable age. You can see gender, that is so the next variable called what? Gender. if you put all these things together, you get a record about what? The first respondent. Okay, so you are gathering information respondent by respondent, right? Then you have what is called what? A data set. So let's take note. One whole row is a record for one person. So if you have about 10 or 20 variables, whatever that person said is a record for that particular person. Let's take note. Okay, so you just come to where you have the age. Then what is the age of that particular, let's say, respondent? If the person is 35, you enter 35 there. Okay, now we have defined gender as 0 and 1, right? So let's assume the person enter what? 0. 0 means what? The person is what? A male. So here you are only entering 01014. Let's say the participant. Let's move to the second participant. The person is what? 28 years and also 0. Then you move to the third participant, which is 39 years, then 1. Then you move to the fourth one. So it's like you will be picking this information from the questionnaires. The paper 1, let's take note of it. So it's like you are done with the first questionnaire, you put it aside, then you pick another one. Then you enter, you pick another one. So if you have about 2,000 of this, right, you need to enter all their records before you have a complete data set for your analysis. And this is very, very tedious. That is why of late we are encouraging the online data collection, because you need to pay people for them to do the data entering for you. And some of them are taking 50 pesos if they enter one record. Okay, So sometimes when people ask us to gather data for them, we let them know the implication of some of these things. That okay, fine. After the if you want us to go to the field to gather the data for you, this is how the data entering. Else, once we are done with the data collection, we will give you the data for you to enter. Then you give it to us for us to do the analysis for you. Because I can't enter this one. Let's assume that we have about 100 variables. So you have age, gender, educational level, religion, whatever, up to 100 item, as against 200 participants. Just look at the kind of work that you are giving us to do. So if you are being asked to pay 1 CD per questionnaire, per one participant, I think it is fair, right? Yeah, I think it is fair because it involves a lot of work. So you need to do all this for all the participants. Then at the end of the day, you will get what? A complete data set. Then you can begin to do your cleaning and then that of the further analysis on the data set. Please, any question? Any question? Please ask all your questions. If you are in the industry, if you are in academia, if you are a researcher doing your research or maybe whatever, you can bring it on board if there's something that you want to understand. Okay, are we good? So I can proceed. So this is how the coding is done and then the data entering is done. So after you are done with all this, right, the procedures are up here. So you can just go on the menu, right? If you want to run frequency on it, you just click on analyze, right? You see descriptive statistics up here, right? And then you select frequency and so on. Please, some of the things might be different from I have a lot of the procedures because I've installed extra extensions to the software. So I have so many things that you cannot see it in your version. In your software, unless you also install same. right? I have a lot of them. So if you are not seeing some of them over there, please, it is normal, right? It is normal. Something like the inequality measures, you don't have it in your end. Okay, so Alex, please, your hand is up. Go ahead. Hello. Hello. Oh, is it Anthony? Say Anthony.
Please, no, please.
Okay. All right. So, so once you are done with the entry, you just go to the analyze, and then you select the type of technique that you want to use to maybe do the analysis. That is all, right? So this is all about data entering or data description, and then data entering. If there's no question, let's take our data set with assumption. Okay, say Alex, your hand is up.
I want to know stance. What level this is all clear.
Hello. Hello.
Yes, sir. Have you heard me?
No, I didn't hear what you said.
Hello.
Hello,
Okay,
please
I
go.
was asking that. I asked that. At what level will you make data cleaning? Is it before coding or after coding?
Okay, so data cleaning should be done after the data is now in your system. Okay, ideally, right? Because as and when they come, right? If you are using a system for collecting, right? You can be cleaning them as the data, let's say, comes in your system, right? That is one way. Another way is you need to also have the entire data set. Once they are in it, you can also begin cleaning. So I wouldn't say that it should be depending on the mechanism that you are using for your system. So if there is your institution is a very huge one that they can buy systems to be hosting data, right? Like what? Let me use statistical service because I've been working with them for some time. They have a system in place that once the data, the field workers are on the field gathering the data, as the data set is coming in their systems, right? There's somebody, we have the data monitors, or yes, the data monitor, they monitor that the information that are coming out are good, right? So their system is quite unique from what maybe we have. So if you are just, let's say, a small person conducting your small research, all that I would say is you do all your data entering. You can enter all your variables. Once you are done, you've entered the data. Now you can apply your data and what's the name? The data cleaning techniques on the data so that you can have a clean data before you start. I hope that is fine. Okay. All right. So let's take any of our data sets. Let's take any of our data set with.
Yes. So my second leg of the question is you talked about installation of extensions in your end, which we are not seeing. If we want to also
Okay. So if you want to install, okay, all right, that is fine. I think maybe I should do maybe a separate and a short video on it for you so that you can get it. So I'll do that. But in simply put, you have to just go to where we have the extensions on the menu. You can see on the menu, we have extensions, right? So you click on the extension. The first option is extension hub. You click on it. Once you click on it, but you need to have access to internet. If you don't have internet, you cannot do it. Now you can see so many extensions here. I don't know whether you can see my screen. There are so many of them here. Depending on what you want to do and your knowledge in its usage, you can click here and install. But as I said, I will do some short video on it as to how you can install some of this package. You can read around it. If you want to use a particular one, then use it for your study. Okay. All right. So having been able to have everything done, let's take one of our data set. Let's take one of our data set and then begin to just apply these basic skills on it. So there is one data I named multiple linear regression. We are not going to start with the regression, but let's just use the regression data, right? So multiple linear regression. Let's use that particular variable for the demonstration. Let's use it for the demonstration. Okay, so I'm going to open the multiple linear regression data. Multiple linear data. So this is the multiple linear data set that I shared with you, right? So you can see the same thing has been done, right? There are labels to all this, right? Now you can see what is called anxiety 1, anxiety 2, 3, 4, 5, and so on. If you don't define it, you will not be able to understand what anxiety 1 is, anxiety 2 is. Like playful 1. If you don't define what playful 1 is, nobody understands what it is. So it is good at all times you define your variables. And then where there is what? Where there is a need for you to give what is the value for, right? Like strongly agree, please do that at the value side. Now, if you click on the data view, this is what you see. So at the end of the day, you will just be seeing just 1, 2, 1, 2, 1, 2, 1, 2, and so on in your data set, right? Per how you have defined the variables. Now, if you want to see what the 1, 2, 1, 2 is, all that I need to do is click on the view on the menu. You see view, and then you click what? Value labels, right? Once you click on it, it will change it to the respective label that you assign to the 1 and then that of what? The 2, right? Good. So all that thing being equal, you have your data set entered. Now you need to perform some cleaning work on the data, right? You need to check whether everything is fine. The first thing that you need to do is 1, run some basic frequency analysis on the data set just to observe whether there is outlier in the data set, whether there is some strange value within the data, whether there is a missing observation in the data. At least it will give you a fair idea about the data set. It is very, very important to do that. It is very, very important to do that, right? Don't be running analysis with missing observations and outliers. It can inflate your results. Instead of you to accept, you are going to reject, or instead of you to reject, you are going to accept, which at the end of the day, it can affect your outcome. Good. So we go to analyze So you click on analyze. We are just going to run frequency on the data. So go to analyze and then select frequencies, right? Select frequencies. So once you click on frequencies, right, you click on frequencies, it will give you another dialog box, right? That has a lot of what? Items in it, right? Maybe if you are seeing the long names, right, just right click on one of the variables, right click on one of the variables and select display variable names. Select display variable names. Once you click on it, you see the anxiety 1, anxiety 2, 3, 4, 5, and so on, right? Instead of the long what names that you've been seeing or the labels, right? So all that I need to do is you just select, if for example, you want to clean only the anxiety questions, okay? You just move them to select all of them at a go and then move them to the box like that. Use the arrow, right? Move them to the box. Then just click on the statistics, click on the statistics, click on the statistics. Here, there are some key things that you need, right? One, you want to check whether there is huge number in the, let's say, the responses that came, right? And then you want to check the distribution of what? The data, whether it is skewed or it is not skewed, right? So here, let's select the minimum value. Let's select the maximum value, right? Good. And then let's select the skewness, and then let's select that of what? The kurtosis. So we are selecting for statistics here. Minimum, maximum, skewness, and then that of what? Kurtosis, right? Good. From here, you can click on OK, or let's say continue. So click on continue, click on continue. So once you click on continue, click on OK, click on OK. Now, you are going to have the results in the other view, which I said that is what the output what view, right? So the results will be in a different what view, right? So let's get to that view. So let me share the view. So I have okay, so this is my output view. So this is my output view. Once you run it, you see the output what view like this. So the first one is the case statistics what table, right? So you have like statistics on each of the items that you what entered, or maybe you ask the system to run the frequency on. So now here you can see n valid for all the items. You can see 378, 378. Now let's see if there is what missing. Missing, you can see 000. So it means we had 100% what response what rate. All the participants provided responses for all the items. We did not get any results. Let's say any missing observation for the 8 questions, 2 for 7 for the 7 what questions, right? So that is good because we don't have any missing. The valid is 378 throughout, meaning we used 378 participants for the study. That is excellent, and we had all of them responding to the questions. Now, we want to look at the minimum and then the maximum. First, you can see the minimum value was 1. Let's say 1 is strongly disagree. And then 5 is what? Strongly what? Agree. And we can see minimum 1, 1 throughout. And then the maximum 2 is what? 5, 5 throughout. So it means that we are within the range of values that we set for ourselves. So as a researcher, these are some of the things that you should be looking out for. So the moment you see a value like, let's say, 50, then it should prompt you that, hey, there is a mistake somewhere. But if you don't have the time to do this, you will not be able to identify, and it's going to affect the result that you are going to get at the end. It is very, very important to do some of these things. It is very, very important. So all this one will help you to know the distribution of your data. Now, let's go into the distribution itself. We are looking at having a data that has a fairly or normally distributed. How do we do that? Research has made us to understand that if we run a test and you have skewness, please let's take note. Skewness and kurtosis values within plus or minus 2. Skewness and kurtosis value within plus or minus 2. It shows normality. In other researchers, they are also on the view that kurtosis can go as far as plus or minus 7. Kurtosis, that is the peak of the distribution. It can go as far as plus or minus 7, right? And then the skewness and the skewness should be plus or minus 2. Please, if you are writing a manuscript, you are writing your thesis, you are writing your whatever report, you need to make reference to some of these things when it comes to you saying a data is normal. Do not just make just a normal statement without backing it with statistics. On what basis are you saying that the data is normal? Who said this or who said that? Please quote the authority and then tell the range of values that they use to validate the normality, the skewness and kurtosis. As I said, in some of the books, they will tell you plus or minus 2. In some books, skewness will be plus or minus 2, kurtosis will be plus or minus 7. So know where you are getting your information from, right? You can check some of my articles. At a point, I use plus or minus 2. At a point, I use plus or minus 7, right? So please do well to do your search before you either say a data is normal or it is not normal. It is very, very important. Okay, so now let's go through the results. Skewness values. Now we have, I am unable to keep up with important advances in new computer technologies. The skewness value is what? 0.47, right? So let's check it for all of them. You can see that they are all less than plus or minus 2, or they are within plus or minus 2. Let's look at the kurtosis 2. Kurtosis, you can also see that they are also less than or within plus or minus 2. So here we can say that our data is normally distributed. Please, it is very, very important, normality test. It is very, very important. It is very, very important. I am stressing on it. I am stressing on it. If you don't want your work to be rejected easily by publication houses, these are some basic things that you need to know. So that if you have a data that is not normal and you have a domain knowledge justification, you add it to it, else they will reject your paper. Because you can't just gather any data and then just assume that this is what the people are saying. Let us know whether their responses are normal or it is skewed, so that they will be informed as to the kind of decision that you are making. Okay, please, any questions? So here we've been able to use the minimum maximum to check whether there is some strange values within our data set. Skewness kurtosis to also help us to know the distribution, whether it is skewed to the left or skewed to the right, or it is fairly distributed. Okay, please, say Alex, your hand is up, followed by Sir Anthony. So please go ahead and ask your question.
Sir, thank you very much. Please, I want to you talked about we selecting about 4 statistical I don't know what to say, but indices or something like that, where you talked about this, the kurtosis and what have you. Which of the icons are we going to use to select that?
Okay, so if you go to statistics, right? You click on statistics. You just click in that button. You see there's some boxes over there, right? Just point your cursor in the box. It will just select. Please, are you okay?
You mean any box or one of the particular box?
Okay, so you click on minimum, maximum, skewness, and kurtosis. So once you click on the frequency and then you see the statistics there, click on the statistics, it will give you the dialog box, and then you can select the minimum, maximum, skewness, and kurtosis in it. Okay. All right. Sir Anthony, your question.
Okay, sir, please. Does it mean that when you are testing for parametric data, you need to test for normality?
Yes, with the parametric, normality is a key. It's a key. Parametric normality is a key. So you need to test for the normality. You need to test it.
Sir,
So
follow-up question.
Okay.
So with this, when you are analyzing the data, maybe writing a report, you have to display the normality test.
Yeah, so you need to present it in a table form. Okay. You need to have it in a tableau form that shows. I think I don't know if I can show you one of my articles for you to see what I'm talking about, because okay, let me share. Okay, so just take a look at this is a paper published in one of the top journals. So this is a paper that I was looking at gender age effect in assessing attitude towards statistics, right? Among undergraduate students using structural equation modeling approach. Now, you can see at the point we did this, if you can see here, you can see skewness, and then that of what? Kurtosis. They are in to assess the normality of what? The data set. So if you see here, you can see that I have written to assess the normality of the provided responses. A skewness and kurtosis analysis, as recommended by Gravita and Bunium 2012, was conducted. According to their guidelines, an item is deemed to be normally distributed when its skewness and kurtosis fall within the range of 2 to -2, right? So some of the authors are saying this, right? Others too will also tell you a different thing altogether. That is why I'm saying I am not limiting you to just one, right? Because maybe you are going to read elsewhere and then you are going to get a different value. So I am exposing you to the other option according to Hare and then Ita. They are saying skewness should be within -2 to 2. Kurtosis should be between -7 to 7, right? So you need to report this tableau, this table. So now you can see descriptive statistics of construct or item. So this table will have the skewness, it will have the mean, standard deviation, skewness, and so on. Everything should be put inside. So have a way to present the results. You can use table to do that. A simple table to, handle your results? Please, are you okay?
Yes, please.
All right. Okay. So after you've done that, you have checked everything. Now you don't have any issue with, let's say, normality. You don't have any issue with what's the name? You don't have any issue with outliers and so on. All I need to do is now begin to now perform basic things about the data, right? Remember the first one that we did, we only check the minimum, maximum skewness, and you can add the mean to it, because as I said, just a small value or just a small high value or a high value within the data can affect the average of what your data, because the mean is sensitive to large numbers. So once, okay, say Anthony, your hand is up.
Okay, sir, sorry for disturbing.
Oh,
Sir,
no
since
problem.
we are talking about normality, so I want to ask, when do you use Shapiro weak text for normality?
Yes, so there are other inferential tests. There are other tests that you can perform to check the normality of for the data. Okay. There are other tests that you can also perform to check. So that is the Shapiro test is there, and then Kolmogorov test is there. We have what's called the Anderson-Darling test. They are all tests to check the normality of what a data set. Are you getting it?
Yes, please.
Yeah.
So in your case, sir, so in your case, which type of test did you use to test for the normality?
Oh, I just use the skewness and ketosis to just do that. They are all tests to do that, right? So it depends. Whatever you want to do, you can go ahead and just do that. Okay. If you want to use those skewness and ketosis, that is fine. They are all tests to check normality. Some even use histogram and other stuff, Keiko plot and so on. So there are so many of them, right? Okay. So that is about you exploring the data, right? Here you can even get a graph of what the data set, the visualization aspect. So if you go to the analyze descriptive statistics, you can select what's the name, frequencies. Then you select what chart. Where you selected the statistics, there is the next option is what chart. So click on it. You can select what histogram, and then even add the normal curve to it. Then this is what you get. Let me show you the results. Let me show you the results for the graph. So the visualization, there are so many of them that you can use. Okay, it seems my system is taking a very long time to run. Running frequencies. Okay, but you can check it at your end. Okay, it is done. So this is a graph, right? This is a graph of your data. But remember, you cannot be putting all these graphs in your work. So why don't you present the results in a Tableau form? So instead of you to present graph by graph in your work, it is better you use the table to present it, report the skewness value, report the ketosis value, and so on. I think that will be fine, right? Good. Please, Sir Alex, your hand is up. Hello.
No, maybe an old hand.
Okay. Thank you very much. So this is one way that you can present. So
it's an old hand.
Okay, so this is a histogram, right? Now you can see that almost all the bars are under the curve. So you can assume normality here, right? You can assume what? Normality here, right? All the items are under the curve for all of them. You can see it clearly, right? So this is what we are talking about. So you either use those skewness kurtosis histogram, right, to do that, or Shapiro, Kolmogorov, Anderson-Darling, and all those tests that you use to perform normality tests. But remember, you cannot put 100 charts in your work to just test for normality. It is not appropriate and it's not acceptable. No publication house would admit that. They will not, they will tell you to remove all of them from the work, right? So it is better you use a table to present or to represent the kind of story that you are what? Telling, right? Okay, good. Please, any other question? Okay, so let's go to our our preamble. So our preamble, we need to perform correlation from the PowerPoint. We need to perform correlation between some of what the variables. Now let's go back. Let's go to our data sets that now we have cleaned our data set. We've cleaned our data set. Everything is okay. We've run some summary statistics to get the mean, to get the standard deviation, to get the minimum value, to get the skewness, the kurtosis. So then we are ready to now do, let's say, some kind of higher test. And one of them is, let's say, correlation. Okay, so we want to perform correlation between some of what? The variables, right? Okay, a hand is up. Or is it an old hand? Please, if it's an old hand, please, you can lower it. If it is an old hand, you can lower it. Okay, say Anthony, your hand is up.
Okay, so I wanted to find out if in running the normality test, I realized that we took the first 7. So with the data set you've given to us, are we going to run the normality test in bit, or we can run it for the entire variable?
Okay.
Like that's what I wanted.
Okay, so what you need to do is you need to run it for all the items, but it will be appropriate. So if you check this paper, the same paper that I shared with you, let me show it again. Now you can see that we had each of the constants. So if you have anxiety, okay, you run anxiety items, then you go to the next what? Construct and so on, and then you do the test, right? Or you run all of them, and then at the end of the day, you try to give them what? Headings. Which of them falls under, let's say, anxiety? Which of them falls under this? Which of them falls under this? Playfulness, and so on. So you need to run it for all of them, but have a way to differentiate this item is under, let's say, anxiety. This item is under satisfaction. This one are under performance, and so on. Okay. Sir Alex,
Okay.
your hand is up.
I think it's an old hand.
All right. So please, just try to lower it. Okay. So I'm taking the correlation. So this is the correlation data. This is the correlation data. So let's see what is the preamble telling us. The preamble is telling us to perform correlation between some of the variables. So we say that using the correlation and covariance data, right, we want to establish some of the correlation or association between the variable. So ideally, the first thing that you need to do, just to give you a graphical view of your let's say analysis, is to perform what is called what? A scatter plot. Okay, you need to perform what is called what? A scatter plot, right? So here we want to establish the relationship by using what? A scatter plot, right? So first, let's go to graphs. You can see graphs on the menu, right? So let's look at that. Graphs on the menu. Okay, then you see scatter, right? So you go to graphs, you see legacy dialogues, and then you click on what? Scatter, right? You see scatter. Okay, now here you can select simple scatter, metric scatter, dot scatter, or whatever, depending on what you are looking at, right? So here we are going to select what is called a metric scatter, because we have a lot of the variables in place, so that we can have all of them on just one graph instead of doing separate. But you can still do separate, just to have a feel of, let's say, the relationship between the variables. So for now, let's do the metrics. Click on the metrics, then click on defined. Then once you click on defined, you can move your variables of interest to the box. Okay, you can move them to the box. Depending on what you want to do, you can add all of them, right? And then you click on OK. So after you have moved all the variables, that is the variables of interest. Here it is variables of interest. You are not supposed to perform correlation for all. It is what you are doing. It is what your study is all about that you need to do. You don't need to waste your time to run correlation for all items. It is not all that necessary. Okay. All right. So here you click on OK. You click on OK. Then let's go and check the results. Let's go and check the results. So this is my results that I see. Okay, this is my results that I see. I don't know, you definitely have something similar like this. Okay, with this one, if you have a technical eye, you'll be able to explain up to a point. If you don't have, you will not be able to explain. Okay, so if what we see here, you can see the variables, for example, performance goal or performance goal. You have achieve, mastery, interest, anxiety, right? So this is all about, let's say, someone who wants to measure his or her, let's say, academic performance, right? And you are measuring it through the achievement that he has made, whether the person has a mastery or the interest or the anxiety level, right? So you want to correlate the relationship between the variables, right? Okay. So, and when it comes to correlation, direction matters. As I said, if it is negative or if it is positive, it matters, so that you can say that, oh, my interest has a negative impact on my performance, right? Or my interest has positive impact on my achievement, and so on. Okay, right. Now, maybe this one is not clear. Let's do it one after the other. Let's try to just do the relationship between achievement and performance. Let's do that. Here, we are not going to use the multiple one. Let's use just the simple one. So analyze, go to the chart, legacy dialogues, select scatter, and then let's say select simple scatter, right? And click on defined. So what do you want to be on the y-axis? So let's say on the y, performance, and then the x-axis is what? Achieve. Then click on OK. Now, when you click on OK, this is what you will see. This is what you see. I think this one maybe will help you to have a better feel of how we have achieve and performance. Achieve and performance is this. Achieve and performance. Where is it? Is this what you see at the top here? Okay, at the top here is achieve and performance, right? Because if you check the y-axis, it starts from gender, anxiety, interest, and it ends at performance goal. And then when it comes to the x-axis, it starts from performance goal achieve, right? So you can see the top here is the relationship between achieve and performance. Now, this chart or this diagram, this scatter that you see here is the same thing, achieve and performance. But here, I think you are getting a better feel of, let's say, the relationship. As I said, direction matters when it comes to correlation. So here you can see, right, that the values are moving towards a certain direction here. Okay. Aha. They are moving, like they are moving from performance coming towards achieve, right? I don't know whether you can see me moving my mouse, hovering it. Can you see it? Is it showing?
Yes, it's showing.
Aha. So that is the movement. And this movement is what is called negative. This is a negative relationship. So let's assume that it goes like this direction to, it becomes what? Positive. Now, let's draw a line of best fit, right? Let's draw a line. So all I need to do is you can just double click in the chart that you see here. Double click, and then just right click on one of the points. Just right click on one of the points, and then maybe you can just add what? Trend what? Line. Can I see fit line to it? Okay. Okay, so now you can see it here. Good. So this is what the system is giving us, right? So this is what we have, right? Good. So now you can see it clearly that it is moving from the y-axis to the x-axis. So this tells you that this is what? A negative what relationship. And you can even see it here. Just look at the values that you see. Y is equals to 49.9 minus. So that is the coefficient that you are getting for the relationship, right? So this should tell you the relationship that what exists between what? The variables. It is what? Negative, right? So this diagram is even helping you to have a better understanding. Okay, so this is how my using a graphical representation, this is how my graph is looking at, or this is how my relationship is looking at, before you even go ahead and perform those correlation aids of using those statistical approach to do that, right? So this information is the same as what you see here, right? But just that this one is giving you more of the picture one by one compared to the combined one. And as I said, you can put a lot of the let's say a lot of the graphs in your work, but you can just put all of them in one box like this and put it in your work. So let's take note. If you have a lot of graphs that you need to show, Most of the time we call it a heap map, right? A heap map, or is it a heap map? Meaning putting all your graphs together as one, putting all of them as one in your analysis. It is better you do it than you do a graph for this, do another graph for that. Then you have a lot of the graphs, which is not appropriate, right? So this is about the graphical representation of the relationship between the variables, right? Good. Now, let's do the statistical analysis. Let's do the statistical analysis. So we go to the analyze, and then we look for correlate. You can see correlate somewhere. Analyze, correlate. Then we select what? Bivariate. So you click on bivariate, and then you select all the variables of interest. Here you can see Pearson. You can see Kanda. You can see Spearman. But remember, at what point are you using Pearson? You are using Pearson when the data is normal. And here we can say that on authority, right? Or per the results that we performed, all the relationships, or let's say all the tests show that all items were statistically distributed, or normally distributed. So we are good to use Pearson chi-square, Pearson correlation for this kind of test, right? Good. So here we are good. We are good. We can use the Pearson for that. You can click on the options. The option can give you more information. It gives you the mean, and then the standard deviation, and then you can also add the cross product deviation and covariance. That is if you need it. If you don't need it, you can ignore. Then the confidence interval also there. You can, if you want it, you can still include them depending on what you are doing, right? So after you have done this, you just click on OK. You click on OK. Once you click on OK, this is the result that you get. So here you can see correlation, statistics table. That is the first one, giving you the descriptives, the mean, the average value for each, right? And then the standard deviation too as well. You can see it over here, right? Now, look at the correlation itself. You can see the correlation results, right? You can see the Pearson value. You can see the significant value. You can see sum of squares value, which you might not need it in your presentation because it's not all that necessary, right? So you have all these values. You need to present this work. You need to present these outputs in your analysis. You need to present this result in your analysis. But the question is, do you need this complex table? This complex table is not appropriate. Now, just take a critical look at the table. You can see 1, 1, 1, 1, 1 showing or going down here, right? Any value above or above the 1 is the same as a value below the 1. So there's no need for you to keep these two values. That is like a mirror. You are the same person looking at yourself in a mirror, right? So you don't need to have the two sides. That is this side and then this side. So why don't you do away with one side? If you want to keep the top, that is fine. If you want to keep the down, it is fine, right? Okay. Hey, a hand is up. Say, Alex, is it an old hand or still new hand?
I think the network is disturbing me. It's an old hand. The network is disturbing me.
Okay, all right. Okay, thank you. Okay, so we don't want to keep both sides. So we go back to the analysis. We go back to the analysis, and then here we select show only the lower triangle. show only the lower triangle. And then we click on what? Okay. So once you click on okay, you will not see the other side, right? You will not see the other side. And as I said, the sum of squares and cross product is not necessary. So let's still go back and then uncheck that option, right? Let's uncheck it. And then at the end of the day, you can see a Pearson, the number of n, significance, and so on and so forth. So this is a very nice table that you need to have, right? And then you just add it to your work. It has also been done here for you. So if you want this one to present in your work, that is perfect. So any of the options that you want to use, you can use it to represent your results, right? I think, let me see if how I presented my correlation. So you can see this. Okay, so this is correlation among such constructs with age. So if you want to go by this method, right, all that I need to do is fall on this particular one, right? If you want to use this one to present your story or to tell your story, please go ahead and use this one, because the association between or the correlation between performance goal and achieve is -2 minus 0.288. Just come here and see, it's the same thing here. The Pearson value is the same. So depending on how you want to present your result, you can use this. And even this side is giving you the confidence interval as well, okay, which has more information compared with what? Just the correlation what alone. So it is very, very important to determine which of these options you are using for your presentation, right? All you need to do is just decide if you want to go by this, you go by that. If you want to use this one, you use this one for your analysis. Please, any question for the correlation? So at the end, you should get something like this. Sir Anthony, your hand is up. You have something like this.
Okay, sir, please. Does it mean if you want to test for correlation, you need to do check for that scatter plot before doing it?
Oh yeah, it is not necessarily that you need to do that, but at least it gives you the pictorial aspect of it, because you see here, you are not seeing any picture. Oh, can you see that? You are not seeing any picture. So you don't really, you are only using the magnitude of the results to determine whether there is correlation, is a weak or is negative. But the diagram can help you to have the pictorial aspect, right? So this one is giving you, oh, okay, so this is the distribution. This is the pattern of the association between performance and then that of what achieve, right? So if you want to, sometimes I do perform the graphical one just to have a feel of it. Once I proceed and then perform the proper one, so that I can get a table and represent in my results, in my report. Is it okay?
All right, sir.
Okay, thank you. Okay, so that is about the correlation between the variables. So here, correlation between a goal and an achieve is negative. So if you are talking about, if you want to interpret this result, right? So then you are saying that the association that exists between performance to, let's say, achieve is inversely related. Okay, so it's like if your performance achieve or performance goes up, right? It reduces your achievements, right? And vice versa. Or if your achievement goes up, your performance also what goes down, and so on. And the impact is approximately, let's say, 28% or 29%, right? That shows you the magnitude of it, right? So, and it is statistically significant. You can see the significant value is less than 0.001, right? It is good, right? So if, let's look at performance and then gender. The Pearson value is negative 0.45, which is, it is small. So here you can see the significant value is 0.598, right? It tells you that there isn't much association between gender and performance what's goal. Irrespective of your gender, if you decide to learn, you will learn. It's not because you are a female or you are a male. That is why you are performing. So here it is telling you that gender has nothing, it doesn't necessarily what associate statistically with what your performance. So you use this table to just do your interpretation, then you go. Okay. Now, please, are we okay with the correlation? Okay. So if we are good with the correlation, our next test is on what is called what? Chi-square test. So chi-square test is a test of association between what? Variables, right? So you can perform chi-square test. Mainly, you see, the chi-square test was designed to look at association between two categorical variables, right? But later they added other information to it that you can perform correlation, association between categorical and then that of what? A continuous what? Variable, right? But if you perform that kind of test, there's something we call cross tabulation. You will not enjoy, or you will not really appreciate the outcome. But if it is categorical by categorical variable that you are finding the association between, for example, you are looking at association between gender and educational level, right? Gender is categorical variable. Educational level is categorical variable. You will see the beauty of the table. But if you perform chi-square test or cross tabulation between gender and income, you will get the result, but you will not really have the beauty of what the tableau that you need to get. You will look into it and then you will see it, right? So there's something we call the effect size, right? So we have what is called the Kramer's V, and then we have what is called the Fine coefficient. This effect size helps us to determine the association, the extent of the association that exists between the variables. Now, at what point do we use the file coefficient? We use the file coefficient when you have 2 by 2 tables. For example, if gender has two levels, male and female, and then another variables too also has 2 levels. So maybe let's say educated and uneducated against gender. You see, educated, uneducated, 2 levels. Gender, male and female, 2 levels. Then you can use what is called the file coefficient to determine the effect size. But if you have a bigger table, right? You have a bigger table, 3 by 3, right? Or 3 by 2, something, anything bigger than just 2 by 2, you use what is called the Kramer's V table, right? Or statistic to do the interpretation, right? So these are some of the basic things that you need to know, because you can write an article on using chi-square. You can write an article using correlation alone for your research work, and it is accepted. You don't need any other thing, because all that maybe you are looking at is maybe you are looking at the association between demographic profile or characteristics on a certain variable, right? So all that you are looking for is association, and you can use the chi-square test to just do that. You will get your manuscript prepared, ready, submitted. You don't need any other test apart from this, if that is all that you are doing. Okay, so now let's use a data. Now let's look at a preamble here. It says that you are investigating whether there is association between gender, male and female, and program choice. So you are looking at male and female. What kind of program are they pursuing, let's say, at the university level? Male and female. Are they going for science courses? Are they going for art courses? Are they going for business courses? We want to find out among university or students. So the admission office collected data on a sample of 100 students, recording their gender and then their academic programs, right? Here, the clue is you are to use a chi-square test to examine the association between what the variables. Please, this is a high dimension what analysis, right? This is a high dimension what analysis. So ideally, all you need to do is you need to formulate what is called what? A hypothesis, right? Formulate a hypothesis, a claim, right? Make a claim that there is, where is my marker? You need to formulate a hypothesis that there is association between, oh, sorry, let me see if I can get. Okay, it's rather unfortunate. I didn't even bring my marker. All right. I wanted to write on the board for you to see, but we can move on. Good. So you need to formulate a claim. And what is a claim? The claim is, let's say there is what? Association between, there is, or let's say gender against, let's say a program what type, right? So the null hypothesis states that, please, am I sharing?
No, please.
No, please, you are not sharing.
Hey.
We can't see your screen.
Okay. Hey. Is it or still?
Yeah, you can
No,
see.
there's still a blank screen.
Okay.
Yes, we can see. You can see there.
Okay. Okay. So here you make the hypothesis that there is no association between gender and program choice, right? So the alternative is saying that there is what? Association. So all that I need to do is you go back to the data or to your test, perform it, and then get it what? Tested. If it is positive or if there is association, just report on it. If there is no association, just report on it. That is all, right? So we are using our data. It says what? Use the chi-square data. So the data set that I shared with you, known as chi-square, this is mine data. This is mine data. So I have mine on the, that is on the data variable view. You can see gender, right? Coded as 1 and then 2 for 1 for male, 2 for female. And then the program type, I have business, arts, and science. You go to the data view. This is what I have. If I want to view what the 1212 is, I click on view value labels. Then I can see it like this. So then here, the male went in for business for the first person. The second person, female, also went for business and so on. So you can see the data set here, right? Good. So here, I just need to go to analyze on the menu. Click analyze on the menu and then go to descriptive statistics. Go to descriptive statistics and select cross tabs. and select cross tabs. So you click on the cross tabs. Then here we have column, we have what? Row. And we all know what a row and then a column is, right? So if you want the row to, if you want gender to be on the row side, right? Where we know this is a row, this is what? A column, right? So if you want it, or you can change it anyhow you want it. So let me put the gender on the row and then program preference on what? The column. Good. Here you can click on statistics. You can click on statistics. If you click on statistics, you will see the chi-square. You will see the chi-square. So just click on the chi-square, right? And then you have, now you can see the contingency coefficient. You can see the file and the Kramer's what? Vein value. So let me just check it. Now, at times, as I said, you will be comparing a nominal data, that is a categorical data, by an interval data. For example, gender against income. It is this side, nominal by what? Interval. So if that is the kind of test that you are performing, you need to select what? Eta. You need to select what? Eta test here, right? So please, let's take note of some of these things. As you can see here, they have grouped all up. So all these are nominal data, ordinal data, and then this is what? By what? Nominal by what? By interval, right? So you can read on the other tools that you see over here, right? They are all good. They can help you to have a better understanding. Good. So from here, you click on what? Continue, right? And then click on OK. Click on OK. Once you do that, let's check the output. So this is the output that you get. So you can see here, gender, right? Gender, and then program profile, or let's say preferences. Among male, we had 15 people who went in for business. 10 went in for arts. 25 went in for science. Within the female, 15 went in for business. 20 went in for arts. 15 went in for what? Science, right? Now, this is the chi-square test. This is where you are going to base on to either say there is what? Association, or there is no association. This is what you see. And then you also have what? The file and that of what? The Kramer's, depending on the number of, let's say, variable levels that you have. So now, here you can add more percentage, because here, these are the absolute values. Now we have 15 people that were males and then went in for what? Let's say business. What is the percentage? So we can go back again and then we select, go to cells, where we select, where we had those chi-square. The next option is cells. You click on cells and then here you can have percentage. So now we have the rule what? Percentage. Okay. Or better still, those of you using SPSS version 27, like the one I shared with you and above, you see the APA, create APA table option there. You can select that one, right? It has a very nice output. So let's, for example, if you have it, click on APA table. If you don't have it, you select the row, right? If you are using the lower version, you select it. Now click on continue. Okay. So now this is what you will get, right? You will get this. So now the system will give you, if you use the AP one, it will give you male, then you have then the number and then the percentage, number, percentage, number, percentage, and you can report it nicely in your in your analysis or in your presentation, right? So this one is giving you more of information. This is of the statistical side. This is just like a frequency count here. This is more of the statistical side. So this is where you need to take a decision. as to whether there is what association between the two or there is no what association. And we are making a decision based on the chi-square value, right? The chi-square value and then the significant what value. Here, the significant value that you see, is greater than 0.05. Okay. So once it is greater than 0.05, here we are going to what? Reject the null hypothesis which we formulated, right? We are going to reject, where is it? We are going to reject the null hypothesis which we said there is no association between gender and program choice, right? If you are rejecting that hypothesis, it means you are accepting the fact that there is what? A significant association between program choice and gender. Because the result tells us that here, let's look at it. If the p-value, right, is small, please let's take note. I don't know whether I stated it the other way. Small p-value means significance. Bigger value means what? Insignificant. But here, we have a big value, a value that is greater than 0.05. So once it is greater than 0.05, so here we fail to reject. So in other words, the appropriate decision is we fail to reject the null hypothesis. In other words, we are sticking to the hypothesis. So what I said earlier on, please, it is the other way around, right? So here, because the p-value is bigger, than 0.05, we fail. So the statement is we fail to reject. We fail to reject the null hypothesis. In other words, like we are sticking to it, or because we don't have enough evidence to say that there is that kind of association between gender and program choice. But if it is less, like in the case of the results here, in the slides, right? The p-value is 0.000. So here we are going to reject the null hypothesis completely and say that there is what? A significant association between the two. But in what we have, right? It doesn't show us that there is what? Significant what? Association. You say there is no significant association. So it means the program that the females are taking is more or less like that of what? The males. So there isn't what? Much significant difference between what? The two, that is gender, and then that of what? The program what? Choice. Please, any question? Are we good? Okay. So if we are good, then okay, a hand is up. Okay. Please go ahead.
Please, can you go over the p-value aspect of the chi-square test again?
Okay, so I'm saying that if the p-value, if it is small than 0.05, which we mostly check or test our results against 0.05. So if it is smaller, it shows significance. And once it is showing significance, we need to completely reject the null hypothesis. But if it is greater than 0.05, here we have 0.054, which is quite bigger. It's quite bigger than 0.05. So here we are not going to reject the null hypothesis. So it's like we are sticking to the null hypothesis. That is, we say that we fail to reject the null hypothesis, or we fail to reject. Right? What is the reason? The reason being that we don't have enough evidence. Anytime you fail to reject, it means you are holding on. You are sticking to what you have for now. But the moment you have enough evidence, you are going to reject it completely. That is what this hypothesis is all about in terms of it being higher than 0.05. Okay, so here it is more than 0.05. So we are sticking to the null hypothesis that there is no significant association between gender and program or choice. Please, is it okay?
Yes, you can go on, Jack.
Is it okay?
Yes, please. You can. It's okay.
Okay, and then here we use if you want to determine the effect size, here it is more than 2, right? And even if you check the results, whether it is the file or the Kramer's V, the values are the same, and then the significant values are also the same, right? As you can see here. And the interpretation is here. That is, if you are having a value close to 0.1, we say it's a small effect. If it is around 0.3, we say medium effect. It is around 0.5, we say large effect. So from what we have 0.0, we have where is it? So we have 0.242. That is the effect size of the Kramer's value. It's around 2. So 2, it's a small effect. It's small effect though, because we've not gotten to 3 for us to say that it is a medium, or it's not above 3 for us to say that it is getting close to large effect, right? So the effect of the relationship between gender and program choice is quite small. A small effect, right? Okay, good. Please, any question? Then we move on to the next test. We move on to the next test. Okay, so this is another test that is of importance, right? After testing for the association, you would like to test for difference between let's say 2 variables, right? So we have what is called the independent sample t-test, and then per sample t-test. We even have what is called the one sample t-test, right? So independent sample t-test, per sample t-test, we have one sample t-test, right? Now, the independent sample t-test. Okay, so your hand is up.
Please, did you share this slide with us? I don't have this particular slide.
Oh, okay. All right. Yes. So this is my master slide. So I'll share this one with you after the presentation. This one you don't have it. So I'll share this particular slide with all of you after the presentation.
Okay, thank you.
Okay, good. So the independent sample t-test is a test that we perform to check differences between independent groups. Okay, independent groups, right? So you are comparing let's say gender, which is male and female. A male is a different person altogether. Female too is also independent, right? Let's get it. We are all human, but I'm just taking it from that absolute level that females are different, males too are also independent, right? Good. So 2 independent groups, we want to find out whether they differ in a certain thing. It could be anything, right? In terms of examination score, performance, employees, let's say retention, whether it is the females that are being kept more in the industry or so. You can perform all these tests using the independent sample t-test. And then the pair sample t-test is when you compare same group of individuals on the same condition, right? So let's say before we even enroll on this program or this training, we should have even asked you, let's say, your knowledge before and then after. Before this training, what was your level of when it comes to data analysis? And then after the training, what is your level? Has it improved or you are the same person? For example, someone who has put on weight, right? Who has put on weight. Before we give you intervention, what is your current weight? After we give you the intervention by giving you some medicine or going for some exercise, after 6 months, we take your measurement again. Have you improved or you are still the same or you have even worsened the condition, right? This is what we say per sample t-test. So if you have a scenario of that type, this is the kind of test that you need to perform. So we don't box all tests using one statistical technique. Every situation when it comes to statistics and data analysis has a unique technique that we use. All right, so that is the paired, independent, and then that is the independent, and then that of what? The paired, right? So let's take the independent data. Let's take the data that I shared with you. So there is a data set that I shared with you that has gender, perceived threats, and then some people's, what's the name? Political affiliation in the United States. So it has gender, perceived threats. Are people being threatening by a group of people? So they were measured, right? Their threat level as against what gender. So we want to find out whether there is significant difference between threat level by gender, or political affiliation by gender, right? Political affiliation by gender, threat level by gender. It is something that we can find out, right? Political affiliation by gender. Even in Ghana, we can perform that kind of test, right? Gender by political affiliation. Which of these political parties can you see more of females or males? As at now, we don't know, right? I think it's a test that we can perform, provided we can get data from EC. We perform some tests on it and get some meaning, get more information about gender distribution by political affiliation and so on, right? Okay, all these studies can be done. No? We can do all these studies, but if you don't have data, you are limited. Okay, so we want to perform the independent sample t-test. So you have your data, gender. So please know how to structure your data in the software to perform a type of analysis. It's very, very important. So here we have the gender variable, we have the perceived trait also here. So we want to find out whether there is significant difference between gender and then perceived traits. Okay. So we go to analyze, and then we go to compare means. Analyze, compare means, then we select independent t-test. Independent t-test, right? Then here we have the test variable. So the test variable is perceived threats. So we move perceived threats here. And then the grouping variable is what is called gender, right? Good. So gender has two levels. At times you might have 3 levels for the particular variable. Let's say level 1, level 2, level 3, right? Okay. So when you come to define groups, you click on the define groups, right? Here, the system has already indicated 1 and 2 for you. But if you have 3 levels, you can decide to compare group 1 against group 3 or group 2 against group 3, right? Gender has just 2, 1 and 2. That is why you can see it 1 and 2 here. But if we have another grouping variable, categorical variable that has more than 2, meaning you have to decide that you want to find out whether level 1 and level 3 associate with a particular variable. Then you click on continue, and then you can click on OK. So once you click on OK, let's check the results. So this is the results that you get. You get this particular results. So the first one is the statistics summary or group statistics. Then you see how many under those that were under threat, or let's say those males under threat. They are 223. Females under threats 181 with their estimated mean values, standard deviation, and so on, right? Now, this is the test itself. This is the test itself to tell you that there is statistically significant between the two variables on threat. Okay, so here you can see the F statistic, the significant values over here. Here you can see equal variance assumed. One of the assumptions under the independent sample t-test is normality and equal variance. We want to have equal variance assume, okay? We want to have equal variance because if the variable do not assume equal variation, most of the times it creates problems, right? So we want them to assume equal variance. Now, how do you determine whether the results here assume equal variance or they don't assume equal variance? What you need to do is you need to come and look for the significant value for the equal variance assume. Okay, they assume equal variance, right? If here, right, if the value is less, I'm saying that we are after equal variance assume, meaning there isn't much variation. So your hypothesis is that the variable assume equal variance. Okay. And then the alternative is equal variance not assumed. It means there are a lot of variation within the data set. So once it is less than this one, then we are saying that equal variation or equal variance assumed, right? Because the p-value or the significant value here is greater. Okay, if it is less than 0.05, then we cannot say that they assume equal variance. It means there is a lot of fluctuation, right? Males are talking about different things altogether, but here we can see that equal variance is assumed, right? Equal variance assumed. Then we come and look for the significant value. So please take note of this. This is a test for equality of variance. This is the statistical test itself. So if you want to talk about whether they assume equal variance or not, you only use this section. So you can see the table, there is clear distinction between the table. You have the Levin's test of equality of variance. And then you have the t-test for equality of means. So once you are done with one, you need to also come and explain the other one, right? Or you can either ignore the equality test of variance, which I know is a key assumption, right? So from here, you come to this side itself to come and talk about whether there is significant difference. And here we can see that there is statistically significant difference between gender and threat level. Let's take note. It is different from variation. Variation, right? Equality of variance. It is different from the test itself. So the first one is an assumption that you need to fulfill. The second one, the test for equality of means, is the test itself, the test statistic for the study. So once they assume, once there is significant difference, it means that the rate at which males and females are perceiving or perceived threat, right, there is statistically what? Significant difference. It means the male sees, let's say threats in a or they receive threats even more than that of for the female. Now, let's go to the table, the group statistics table, and see. Look at the average value for gender. Male, we have 2, 2, 3. The mean value is 3.41. Look at that of female. They are just 181. But just look at the number. The average is 3.79. Just look at how they are saying that they are being threatening, right? If it is a scale of 1 to 5, and where 1 is disagree, I disagree that I am being threatening. But if it's getting closer to 5, then it means the people are saying, I am strongly saying that I am being threatening. And the value is 3.7 what? 3.79, right? Telling you that there is what? Significant difference of almost 0.11 something, right? And so on. This the mean difference of 0.12377 difference. That tells you how significant it is between what the two groups, right? So this is a test to tell whether there is significant difference between two groups. Please, it is two independent groups. If you have more than two groups, this technique is not appropriate, but rather you need to use what is called analysis of what? Variance, one-way ANOVA. Please, any question? Are we tired already? Ah.
Yes, sir.
We are tired.
Hello.
Hello.
I think we have not even gone for even small break. This is how the Zoom always looking. And you know, it's good to drink water and then some of us take supper out and things.
Yeah, you can take water.
Okay, sir.
Okay. So the next one, we are looking at the one-way analysis of what? Variance. We will finish very soon. Analysis of variance, which I said is one of the powerful tests, because it is not all the time that you'll be having two groups that you are comparing. A time will come you'll be having more than what? Two groups. So here, if it is male and female, it's going below beyond male and female as a level. But rather, maybe you have, let's say, a variable like educational level, you have primary, secondary, tertiary, or whatever it is, which has more than two levels. And you are comparing these levels against, let's say, income, right? So the independent t-test that compares to, you can use that one to do, but it will create problems for you. Yeah, it will create problem for you, because if the error margin in the study is 0.5, right? Instead of you to use a powerful technique that can do the analysis at a go for you, you rather chose to use a limited one, right? To perform the test one after the other. So if the error is 0.05, right? If you multiply it by 3, that is how you are going to get for the new kind of what analysis, which is very, very poor. It is not appropriate. So if you have a test that can accommodate all your variables, it is appropriate you use it, right? It is appropriate you use it to do your analysis rather than to just go and perform t-test one after the other. Okay, so let's take our data. There's a data set. There is a data. So now let's take a preamble. Let's take a preamble. I think we've looked at this one already. Okay, and okay, you are conducting a study testing whether there is a significant difference between individual identifiers. Okay, we have looked at this one already. So let's take the ANOVA question. Okay, so now what is the preamble? It says you are conducting a study to examine the role of 3 motivational interventions right? 3 motivational interventions. That is A, B, or C on student academic motivation, or let's say on student performance. There are some interventions that you are putting in place to help students, to encourage them to achieve academic excellence. Or you are putting in certain interventions at the workplace to encourage employees to do more, right? Or you are putting certain mechanisms to at least to have certain activity to go on well in your organization, right? So you have 3 interventions. So the interventions are there, and then plus that kind of what score that you assign for the intervention. So let's take the one-way ANOVA data. One-way ANOVA data. Okay, so I have so this is my one-way ANOVA data, right? Okay, so the interventions were measured 1, 2, 3, right? As against the academic motivation, the students' motivation level were measured using, let's say, a scale, right? They use a scale to measure their motivation level, or they were asked to rate it on a certain scale, right? Let's say 1 up to 50, or 1 up to 60, or 1 up to 30, or 1 up to 40, and so on, right? So we need to perform this test, the intervention against that of what the motivation scale, or let's say variable. Okay, so we go to analyze, we go to analyze, and then compare means the same place. Then we select one-way ANOVA, right? So here we put the grouping variable here is the motivation level, right? So move the motivation intervention or level to the factor, right? And then the academic motivation, that is the continuous variable, to the dependent list, right? Okay, you can check the effect size just to tell you the magnitude of the effect, right? Okay, here you can, if you want descriptive statistics, you can check for descriptive statistics. And then if you want a plot, well, let's select a plot. That is on the option, and then you click on what? Continue, right? Click on continue, and then you click on what? Okay. So once you do that, this is the results that you get. So you get descriptive statistics for the intervention A, B, C. So under the intervention A, we have 12 people under it. Intervention B, 8, C, 10, and so on, with their estimated mean, standard deviation, errors, and so on, right? Okay. So after this, the next table is the ANOVA itself. This is what we are looking for. This is the table itself. But let's explore. So you have the effect size, you have the means plot too, right? So the ANOVA, which is a test to tell you whether there is a significant difference or there is no significant difference. So now let's go to the ANOVA test. So here, academic motivation, that is the ANOVA. Go and look for the significant value. The significant value here is less than 0.001. So that tells you how significant difference the various interventions, right, had on student academic motivation. It is very, very important here for you to take note of this, because if you can see significant difference, this is where you will be motivated, because as it stands, we don't know where the difference is coming from. Okay, so once ANOVA tells you that there is significant difference. The next option is to find out where the significant difference lies. Okay, so, and just the descriptive will not be enough for you to say that, oh, the intervention A had a mean of 25.52. So it is less than the B, which is 34.50. Here it is descriptive. It is not statistically. It is not statistical, right? When we talk about statistical analysis, it's not about the descriptives. It is the proper tests like ANOVA, chi-square tests, correlations, and so on. They are the statistical tests, not the mean, standard deviation, and so on, right? Okay, so here we only see that there is significant difference between all for the three interventions on student academic performance, right? How do we determine it? How do we determine whether it is the difference is between group intervention A and the intervention B, right? We want to find out whether there is a gap between the intervention A and then that of intervention B, or the interventions are the same because none of them is contributing to the student academic performance. But what we have here, we can see that the software, or let's say the program, is telling us that there is what significant difference, or there is a significant gap between the intervention. So after we've been able to determine where the difference lies, then we can say that, oh, okay, then it is intervention C that is contributing more to the student academic achievement. Then we come back to this particular table. So please, let's take note. So this first table is important. This is very, very important. And then we have what is called the effect size, right? The effect size, which we indicated in the other side. But here we use what is called the eta, right? We have the eta squared to determine the effect size and so on. Okay. All right. So once ANOVA tells you that there is what significant difference, as a researcher, you don't end there. You don't end there because you can't just go and tell your boss that when I did a test, it tells me that there is significant difference between the three interventions on employees' performance. Your boss will definitely ask you, okay, so which of the intervention is contributing more? That is what your boss will ask you. Your boss will not just tell you that there is no will not just be mute and say that, okay, you are saying there is no significant difference, so that is all. He or she will like to find out where the difference lies. Okay, so we perform what is called a post hoc test. We perform what is called a post hoc test, right? A post hoc test. It is a test that is necessary if ANOVA tells you that there is significant difference. If ANOVA tells you that there is no significant difference, don't worry yourself and perform any post hoc test because you won't see any difference. The difference will not be anything significant. They will all be the same. Okay, so how do we perform a post hoc test? How do we perform a post hoc test? You go to the same procedure, ANOVA, and then you select post hoc. You can see post hoc test here, right? And then you click on it. Now, if you click on it, there are a lot of statistical procedures here, right? We can't have the time to go through all this, right? So we have what is called the equal variance assume, and then equal variance not assume or test, right? Okay, so here we are making an assumption that equal variance is what assume, which is a requirement for ANOVA, right? So if that is the test that we are looking for, then we are saying that we want to use the commonly reported statistic. Here we use what is called the TECI. You use is it the Tukey? You use the Tukey, anyhow I want to pronounce it. So the Tukey or the TECI test, that is the most reported test. So you select this particular test and then you click on continue, right? And then you click on OK. So once you click on OK, let's see the results. It gives you the same results, but it adds another feature to it. That is what is called the multiple comparison test. Multiple comparison test. So this is where you can see how the system compares each group by another group. So group A against group B, group A against C, group B against A, group B against C, group C against A, group C against B, and so on, as you can see it over here, right? So we've dealt with the top one. Let's look at the multiple comparison test. That's the post-hoc test, right? So here, let's look for their significance. So there is you can see significant value here. That is, the value is less than 0.005 or even 0.001, right? It's less than 0.1, right? So it tells you there is what? Significant what? Difference. Now, so here we can say that there is a significant difference in intervention A and then that of what? Intervention B. Now, let's go to intervention A on the descriptive table. Intervention A had 2.25.52. Intervention B had 34.5069, right? What is the difference in terms of what? The gap, right? It's almost about what? 8.98, right? The absolute difference is about, let's say, approximately what? 9. That is huge. Okay, 9 points. That is quite what? Significant. That is why you can see what a significant what value here, right? So it tells you that intervention B, right, is contributing more to student academic performance than that of what? Intervention what? A. Okay. Now, this you do same, you compare A and then C, right? Also significant, right? You can go to the descriptive table, A and C. A is 25.52, B is 30.34. What is the mean difference? It's almost around what? 4.8, approximately, let's say 5, which is also what? Quite what? Significant, right? So that is how you present your results, or if you want to discuss, you discuss it in this what manner, right? So it is very, very important. It is very, very important to know some of these basic things that you use when it comes to the report, even the report what writing. And there are more information, right? We've shared more information with you, right? So if you take the supplementary material on ANOVA, you will get more information. We've explained it in details, right? As to how you should even what present your result and so on. Please, any question? Any question? Any question? Hello?
If there's no question, I think we can continue, or you can, yes.
Okay, so then let's continue. So let's go into an regression in brief, right? Let's go to regression in brief. Let's go through and then we take the data. So regression, okay, a question, Sir Anthony. Sir Anthony, your hand is up. Or is it an old hand?
No, sir, it's a new hand. Sir.
Yes, sir.
Hello.
Hello.
This is the you sent, the another one.
Yes.
I can't open it. I want to ask, which app can be used to open it.
So it's a PowerPoint slide. So you just need PowerPoint on your computer.
Color.
That's oh, which one are you talking? Is it the data? If the data, you need the SPSS software to be able to do that.
The one in blue color.
Blue color.
Yes. The ANOVA file.
Yeah, that is it this
Yeah.
one?
So
This one.
you sent multiple linear regression. You sent independent sample t-test, but that of the ANOVA, but I can't be open.
So you need SPSS. You need to install. Having to install the SPSS software.
I'm talking about the one. I'm talking about the files you sent. You know,
Yes.
the one we are using ANOVA data. The which is contain the data regarding ANOVA analysis. Particular file, I can't open it.
But do you have SPSS on your data on your computer?
Yes, please.
And we were able to open what's the name? The correlation one.
So okay, you continue. Continue.
Okay, maybe after that we can talk about it. Okay, so we are looking at regression. Regression is one of the most powerful techniques when it comes to statistical analysis and even modern analysis, right? So
Yes, please.
okay, so you need to have a better understanding when it comes to its usage and how it can improve.
All right.
And how it can improve your research work, right? There are so many types of regression. So many types. There are so many. More than 10, 12 or thereabout. There are so many, depending on the kind of task that you want to perform, right? So we talk about regression by looking at the linear one. If it's about the linear one, then we have what is called the simple linear regression and then the multiple linear regression. So the simple linear regression is we are just looking at one dependent variable. And then the multiple linear, you are looking at one dependent and then a lot of independent or two or more independent variables. That is all, right? So if it is about simple, then we are looking at predicting student final grades, that is the Y, based on their number of study hours. This is one dependent, one independent, right? But if you also want to predict a person's weight based on the person's height, the age, the cholesterol level, plus other variables, here you can say that, or you can see that you have a lot of the independent variable, right? So here it becomes a multiple regression, not a simple regression, right? Okay, so we just want to perform some of these tests or this regression analysis for us to understand. Now, we have a preamble that is trying to examine how people respond to modern usage of computer application, right? So a lot of questions were designed, or let's say were taken into consideration, right? Were taken into consideration. That is what you see in the multiple regression, this particular data, the multiple regression data, right? This particular one that you see. So we want to find out, let me even read the question. It says, to what extent do individual perceptions such as anxiety, frequency of computer use, playfulness, social engagement, ability to acquire information, perception of usefulness, and decision quality predict productivity at the workplace? Okay, so if you look at the data set that we have, we have anxiety, we have computer use, we have playfulness, we have their social engagement, we have their information acquisition, we have their decision quality, and then we have what their usefulness. So if you look at this preamble very well, right? We just want to find out how all these variables can influence. Okay, now, when I started, I was comparing the exploratory against the confirmatory, and I said that would be the next thing that we will be looking into, right? Now, there is something we call composites. You need a composite analysis. Composite analysis simply means that you have questions such as anxiety 1, anxiety 2, anxiety 3, all measuring what is called anxiety, right? And then computer use 1 up to 4, also measuring computer use. But at the end of the day, you want to regress, let's say, anxiety on computer use using single what? Variable called anxiety. One variable called computer use, one variable called playfulness, right? Later on, I will show you how you can, like in our the subsequent training, something like this, right? Here we maintain all the variables in it, anxiety 1, anxiety 2, anxiety 3. This is more complex. And if you're able to do research in this area, it is regarded as more robust, right? It is more robust to be able to tell a story, right? So as we move on, we will be doing a training on this area too as well. But for now, we want to composite all the items and have one variable called anxiety, and have one variable called computer use, playfulness, and so on. How do we do that? Because we need to composite first before we begin to do the regression analysis, right? So all that we need to do is we want to composite all these variables as one, right? So we just go to transform on the menu, transform, and then you click on composite variable. Here you can type anxiety, okay, anxiety, but make sure what you are typing is not already in the data, right? It's not already in the data. So anxiety, and then you move all the anxiety questions, you find the mean, so you can type, you come to this side and type what? Mean, right? And then you move all the anxiety, move them one after the other by introducing a comma. By introducing a comma, like this, and then you close it nicely, and then you click on OK. Now, once you click on OK, the system will composite all of them. So now you can see there's one variable called anxiety. Okay, here. If you go to the data view, you see the anxiety here, right? So that is how you need to do all the items, right? I know those of you who are doing your master's or MPhil or PhD, you've been collecting data on this level, which is it's one of the things that those in humanities have been doing a lot, right? So you have a lot of items measuring a certain construct and so on. So this is, you can composite it in this form, right? So this is one. You can do the other one. Let's say computer use, and then do away with all these items, and then you move the computer use items to the box by introducing a comma, right? Introducing a comma, and then you click on OK. So that one too, the system would what? Do it for you. let's do another one, and then I think we can end this particular one and use the result for the data. And then let's say usefulness. So let's type usefulness, and then we look for usefulness items, So comma here, comma there. Okay, and then we click on OK. So at the end, you have three, let's say, main constructs here: anxiety, computer use, and what usefulness. So if you want to run regression on it, right, per the preamble, we need to regress all this variable on usefulness. Okay, how it says, and decision quality, predict productivity at the workplace. In other words, that is the useful aspect. How is it helping to improve? Okay, so you regress all the other independent variable on the dependent variable. That is so usefulness. But I think we can just use this true independent, and then later, or you can just do it once you have the data. You should be able to run the rest. So you go to analyze, and then you go to regression. Now, this is what I was talking about. You see, I have installed a lot of packages. So here I have almost about 12 types of regression. I have linear, curve, regression, relative importance, partial least square regression, discontinuity, and so on. You can see, once you're able to install the packages, you will get a lot of the types for different tasks. Okay, so here I go to regression, select linear, right? And then I locate my dependent. So my dependent variable here is usefulness, and then anxiety and computer use becomes what? Independent variables, right? Here, there is an assumption that I need to fulfill. Right? Collinearity, that is, I don't want the situation whereby there will be too much correlation within my data set. So what I need to do is to check for collinearity diagnosis in the analysis. We use what is called the variance inflation factor. And once the variance inflation factor is greater than 10, or it's getting close to 10, or once it's above 10, then you should suspect what is called collinearity. It is very, very important to take note of that. How do you check this option? So you can click on the statistics. You can see collinearity statistics or diagnosis. So you click on it. You click on collinearity diagnostics, and then you click on continue. And then I think you should be fine by clicking OK. Once you click on OK, you will get this result. You will get this output, right? You will get this output, model summary, ANOVA, coefficients, and so on, right? You will get this particular result. So this is also showing you summary statistics. That is the model summary, the impact of the independent variable, that is the two independent variable on the outcome variable. Here you have the R and then that of the R square, right? So here it's telling you the relationship that exists between the independent variable on the outcome variable, and it is very small, right? It takes value from 0 to 1, and here you are having about 28%. And look at the R square, and the R square is the most important statistic, right? It's the most important statistic, and it is not even close to 1. That is weak. So that tells you that the impact that the independent variables have on the dependent variable is weak, right? It is what? Very weak, right? Then you come to the ANOVA. ANOVA is telling you that there is a significant variable. So at least ANOVA is telling you that the fact that there is a weak impact of the independent variables on the outcome variable, yet there is a significant variable in the model, right? So you come to the coefficient table, and then you can see the significant value for anxiety is 0.032. That tells you that anxiety is contributing to usefulness. And then that of the computer use is also contributing to what? Usefulness. So the two variables, the two independent variables are all statistically what? Significant. Now check the variance inflation factor, right? The VIF, the variance inflation factor. You can see that they are all less than even 2. So that tells you that all the variables in the model are independent. They are statistically what? Independent. We don't have any issue when it comes to collinearity what? Issue, right? So this is about regression, how you should present your regression information in your analysis. So for example, if you were looking at the impact of, let's say, all the variables on the outcome variable, this is how it's going to look like. So we'll be looking at decision quality on usefulness, anxiety on usefulness, computer use on usefulness, and so on. This is how it's going to look like, right? So let's take note. Let's take note of some of these basic things that we are talking about, right, under the regression model. Now, the last one, then maybe we can end, is what is called the hierarchical regression, right? Hierarchical regression is one of the techniques that it has been used in health science and other related areas, right? So sometimes you take people's articles and you'll be seeing types of model like model 1, model 2, model 3, and so on and so forth, right? For example, if we want to examine how like using like what we just did, okay? What we just did by looking at usefulness as a result of was the anxiety and that of computer use, right? As one model. Now, if we should add another set of variables to the model, what will be the impact? So this results that we have, right? This results that we have, we can call it model 1. We can call this particular model as what? Model 1. Okay. Then once you do the test, we keep all the statistics for this particular one. Then we, let's say, run another one too, including a variable like, let's say, gender or age, age to the model, and see how it works. How do we do that? The same regression procedure, right? So what you do is you just click on next. Okay, you click on next. This same thing that you did, you click on next, right? You click on next, right? You click on next, and then the moment you click on next, you see block 2 of 2, right? Then you can move the new set. That is what, let's say, maybe you want to check after adding a variable like age or let's say gender, what is the impact? Are you getting it? So you just click on OK, and then you run it. So once you run it, this is the results that you get. Let's look at it. So here you can see the first session. The first session is here, right? You have the first session and then the second session too, right? And the system too would try to separate the two results for you, right? It will separate the two results for you, as you can see over here. So you have model 1. So this is model 1. This is also model 2, right? With their respective results, right? So here you can determine whether the variable has contributed or not to the model. When it was only this, right? When it was only this, what was the impact? We realized that anxiety was significant. Computer use was also significant. After adding age and gender to it, let's see, anxiety still was significant, computer use was significant, but age was not significant, and then gender too was not significant, right? And now let's look at the impacts. Let's look at the impacts of the analysis. The R-square value, right? At the initial level, it was what? The R-square value. It was 0.082. Now, after adding two variables to it, it came to 0.089. And this value is not all that statistically significant. It is not all that significant. So it did not change a lot. It did not have a lot of impact on what? Our analysis, right? And you can clearly see over here that the two variables are not statistically significant, gender and age. They do not contribute. So you can exclude it from what? Further analysis, or you can exclude it from your data, right? Or from your analysis, right? So this is what we call the hierarchical regression. Hierarchical regression or model building. You build model step by step and so on, right? So this is how the presentation is done. You can present it like this, okay? So let's say at the initial level, only demographic profile on the, let's say, the dependent variable. What result did you get? What was the R-square value, the difference, and so on? And then after you adding the other variables to it as model 2, what did you also get, and so on? And this is a formal way of presenting or maybe making a statement about your result. So it says a hierarchical multiple regression was conducted. So at all times, you need to be able to come out and state what you are looking at. So a hierarchical multiple regression was conducted to examine whether perception on computer, blah, 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 and so on. In model 1, age, gender, this one, blah, 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 and so on, and blah, 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 and so on. So this is how you need to present your results, right? You need to present your result when it comes to hierarchical, what's the name? Hierarchical regression approach, right? Please, any question? I'll share the slide with you with all the necessary information that you need. There are some papers that I also have, and I'll share all of them with you, and can also help guide how you can, enhance your analysis. Please, any question? Any question? Okay, so we are, okay. Sir Godfred, your hand is up.
Yeah, hello, good evening.
Yes, sir.
Yeah, thank you very much for the presentation, and we really liked it very well. So after this presentation, I think we'll go through. Is there a chance that after going through, we can ask questions, further questions after this lecture?
Oh yeah, so you can send emails, the emails that you receive the information from. you can send emails. You can send us WhatsApp information to WhatsApp message, and I think we are there. We are there for you, right? We are there for you. If there's something you don't get it, you can reach out. Yeah.
All right. Thank you very much.
Yes.
Thank you very
Okay.
much.
Okay.
So when will be the next one?
Maybe in a month's time. In a month's time, we'll be looking at what is called the exploratory analysis. And the exploratory, you see, what we are looking at is exploratory data analysis. There is exploratory factor analysis. So that is also a whole thing on its own. So we will take that one, exploratory factor analysis, right? And then we will take the confirmatory factor analysis. So the next session will be the exploratory factor analysis. And then after the incoming one, we will take the confirmatory factor analysis. But for the time being, you can just go online, go to Google Scholar, to get scholarly articles in exploratory factor analysis. Just see the kind of research that people have done around exploratory factor analysis. Or go online and search for articles that have been done using hierarchical regression. You see a lot of articles. So sometimes if some people are not making use of the statistical things and they are just running frequency and all those kind of things, it's quite a worrying. When you have techniques that will be able to make meaning into your data, you are rather using those frequency small percentage. They are just descriptive. I'm not saying they are not good. They are good. But there are tools when it comes to decision making. We should be able to know them to help us to even write quality articles for publication purposes. So once again, I thank you very much for this opportunity. And if there is any issue, you can reach out. If you have some work that maybe you don't have the time, you don't have the skill, you want us to work on it for you, we are there to help you out to solve all your data related issue. Okay, so Sally, your hand is up.
Yes, please. I want to find out the version of SPSS that was shared to us. If we can get the maybe 29, at least I think that was 29. I don't know whether you have that one for the crack version of the SPSS version 29.
Oh no, I don't have it. This is even more okay for you.
Okay.
Yeah, this is okay. Yeah.
Okay. The other concern is the video, as we suggested, should be recorded from the onset. Maybe after this, you can share with us on the Google Drive so that we can use it to go through it again.
Yeah.
And when we have issues, then we can reach out to your outfit. Thank you.
Sure. So the recording, once we end the class, the recording plus the PowerPoints will be made available to you. Once we get it ready from the cloud base, we will share all of them with you.
Okay. All right. Thank you.
All right. Okay. Okay. So if there is no further questions, then I think we will end the class for today. Let's continue to work hard. Let's take our research to a different level. Let's begin to write papers. That is the only way that we can apply some of these skills. If we learn, we do not apply within 1 month, 2 months, it will look as if we've not even done anything at all. So I'll urge all of us to make good use of the statistics to make informed decisions rather than to use our intuitions to make decisions, which is not helping all of us as a country, as businesses, and as individuals, because we don't base on data, we don't base on scientific approach, we don't base on statistical approach, but rather I think I should do it like this. I think I should do it like that. And it's affecting all of us. So thank you very much for having time. Those that could not also join because of network, we will share the slides with them. I think we were about 17 or 18 people registered, but we could not even get 10 of them joining. But some did send a message that because of network issues or electricity issues, they could not. So once again, we will share the information with all of you. Thank you.
Thank you. Thank you.
Thank
Thank you
you.
very much. We are grateful.
Okay. All right.
God bless you.
Right.